So we had this warm up. Wilbur the guinea pig is eating 4 pieces of lettuce every day. I can get this to disappear. And we needed to create a graph. How did those graphs turn out?
Pretty good. Pretty good.
Okay. So what were we going up by on our graph? Or how much were we increasing by every day? 4. Okay, so what did you make your scale of your graph? Just curious.
I went by 2.
2? By 4?
I went by 4.
4. Okay. And that's really up to you. If you want to go by 1s, you can. You might just be a little bit steeper than someone else who went by 2s or who went up by 4s. By 6? It's an interesting choice of. All right, do we have any questions about graphs or being able to create the graph, anything like that from yesterday? All right, let's put your shoes back on, bud. All right, so we have this situation of Wilbur eating 4 pieces of lettuce a day. This
The guinea pig is dead.
That is awesome. All right, give me one moment while I grab another battery for this.
Could you please not show my life forces right now? Like,
Okay, so Wilbur ate pieces of lettuce. All right, so how many pieces of lettuce would Wilbur have eaten after 8 days? 32. How do you do that, Dylan? You looked at your graph. You went all the way up to 8 days, and you have 32 on there. Okay, what's another way to look at yourself that? What was that, Sheila? 8 times 4. 8 times 4. Why did you do 8 times 4?
4 pieces of lettuce each day.
So you have 4 pieces of lettuce per day for 8 days. Good. What about 17 days? We can do 17 times 4, which whatever that turns out to be. Let's bust out the calculator just to see what we get. That's a lot of lettuce. 17 times 4 should be 68. What about 999 days?
3,996. You did that all in there. I'm totally guessing. I have no idea.
What did you say it was?
3,996. What?
Is that right? 3,996? Is that what you said?
Yeah, all you gotta do is,
Yeah, it makes sense. 9. Yep. Because it's like 1,000 except minus 4. Good. Awesome. All right. What if I said, so, or what are you doing here? What's going on? What's happening? Eating guinea pigs, okay. How are you determining these answers? What? Okay, let's be a little bit more specific. Multiplication. What are you multiplying by every time?
4.
And days times 4. What variable did we use to represent our days in this situation? What variable? I mean, I can use lettuce as a variable, but was that my independent variable or my dependent variable? It was my independent. That should have been the bottom part of your graph. Remember, the bottom part of your graph is always that independent variable, that time, while the y part of your graph is always going to be your dependent variable, representing an amount. So what variable goes with the bottom part? What letter? X. So x is going to be my independent variable. So I'm multiplying x by 4 every time. And this told me my dependent variable, what my answer would be. So depending on what number I put in for x, I multiplied that by 4, and I got an answer. What did I just create right here? What do we call this? An algebraic equation.
No way, really? You have a lucky day. Wow.
So we have an equation here. So depending on whatever day, you could choose any day, you could plug that in for x, and you could figure out how many pieces of lettuce Wilbur would have eaten after that number of days. And so we can use this equation for all types of things. So that's what we're going to talk about today. We're going to talk about how we can form these equations based off the situations that we're given. Any questions so far, or where we pulled any of this from the moment? Yes?
Wilbur, your guinea pig?
Wilbur is my guinea pig. She's my favorite. Don't tell the others. That's what we just did. All right. So before we get started, when we talk about algebraic equations, when we talk about these linear equations, and we're going to emphasis on the word linear in a bit, we have a generic formula. And you may have seen this before from Math 8, you may not have. But this generic formula is y equals mx plus b. And so each of these letters represent something. So just like we talked about before, that y, that's your output, that's your dependent variable. What is the result after this? After you input something, what is your answer? Your x, that's your input after so many days, after what number are you inputting into this equation, what are you changing? Our m, we're going to call that your slope. Does anyone remember the word slope from last year? And like, what was it, positive slope and negative slope and horizontal slope and inclined slope, and you had to do all those calisthenics, is that what you called them? I can't remember. Simon Says that's what slope Simon Says. But our slope is going to be what we call our rate of change. That's how much we're changing by. What was our slope from the last situation with Wilbur? How much were we changing by every time? 4. So we were increasing by 4. Every day we were increasing by 4 pieces of lettuce. And so that would be our slope would be 4. Now, do we have a number on the end in that last situation? So we had y equals 4x, but we didn't have that plus or minus something at the end. That number at the end we're going to call our y-intercept. And so anytime you have a starting amount that's not 0, anytime you, like, say Wilbur started with 8 pieces of lettuce before we started counting, that 8 would be your y-intercept. Anytime you have an initial amount or a starting value, that will be your y-intercept. And this is also, when we start graphing things, this is where it'll interact on our y-axis. So this is an important formula to remember, y equals mx plus b. Any questions about anything I just talked about on the board? All right, let's practice this.
Can I do this one real quick? Say no.
No, go ahead. I mean, yes, go ahead. If that was confusing. All right, so we have a volleyball player. This volleyball player has spiked the ball 2 times so far in her career. I don't know if that's a lot. I don't know if that's a little. I'm not very familiar with volleyball. You guys can tell me. So her goal for this season is to spike the ball at least 3 times per game. But we want to create an equation that represents the number of times she would spike the ball after so many X number of games throughout this year. So we're going to use this y equals mx plus b to help us formulate our equation. So we know it's going to have that representation. So y is going to be our output, x is going to be our input, and we're going to have some initial amount and some slope. So how many spikes did she start with at the initial amount? 2. So that is going to be our y-intercept. Is that plus 2? How much is our slope? How much are we increasing by every game? 3. And so that would be our slope for our situation. And so that's as easy as it is to create an equation. So we just have to pull that information from the situation, understand what does each of those pieces of information represent. X is going to be your number of games. Y is going to be your answer at the end. That's the number of times she will spike. 2 is your initial amount. 3 is how many times she's increasing by. So as long as we can understand what each of those pieces mean from the problem, we can easily create an equation. Are we okay with this?
Sir, yes, sir.
Have we seen this stuff before?
Yes.
That's good. That makes it easy on me. All right. So we have this y equals 3x or 3x plus 2. Now let's graph it. So I'm going to give you some nice graph paper to do this on. What?
Graphing is too hard. Graphing hurts my soul.
Go, baby. Thank you, Ellen. I got it.
Here's something else for you to do.
Miss Brad, Miss Henry.
Push up.
I'm going to push up.
Sorry, if I do push-ups, I'll kill myself.
What do you mean? What?
Oh, how about I trick you? Push yourself once, and then I trick you again.
Oh, we're still there up there?
I'll get to it.
Thomas, can you do 10 push-ups?
Hardly. Do I look like I can?
Oh, no. Look, you don't have to be mean. You can do it.
That's possible. That's what's fine.
You look like a Star Wars.
All right, let's have a seat. Let's have a seat. Okay, so we want to graph this equation. So we have this situation of this girl and her ability to spike volleyball, and we want to graph this. So you should have a graph like this on your paper.
No, I don't.
So when we graph, what are some strategies we can go about to graph, to help us graph? What can we do to help us graph? What can we do?
Graph
Where do we start?
at the graph line.
These
So there's a couple strategies we can go about. So one thing we can do is we can make a table. That's one way to start, and that always helps. So you might not have all the room on your paper, but let's do a quick XY table to at least get us started.
We're on now.
All right. So for my XY table, I'm just going to input some numbers in here. So I'm going to start with 0, we'll say 1, 2. We'll just start with this for now. If I put 0 into my X, what will I get out as my output?
0.
1.
So I'll have 0 times 3, because these are being multiplied, which is 0, plus 2, so my Y is 2. If I put 1 into my X, 3 times 1,
2.
plus 2, 2
Oh.
times 3, plus 2.
Hey.
It's just going up by 3 every time.
It's increasing by 3. Why is it increasing by 3?
Because math.
Because my slope is 3. So whatever we're increasing by, we call that our rate of change.
So if you can figure out the third one, I think I'm going to look at.
Yeah, if I want to keep going, I know I'm going to increase by 3 again, so it's going to be 11. I can keep on going. So if I were to group these two pieces of information together, 0, 2, what did I just create? What do we call this? An ordered pair. So this is an ordered pair, or a coordinate point is another name for it. So in order to plot this, I can look for 0 on my x-axis, which is going to be right on my y. And then I can go up 2 for my y. So there's 0, 2. I can keep going. 1, 5. Start at 1, go up to 5. Go over to 2, up to 8.
I did.
So that's how a table can be helpful getting us started. What if I wanted to keep going? Or what if I wanted to extend back farther? How do I need to keep creating points on my table so I can keep knowing where to plot these things? Or is there an easier way to go about this? So I know I'm increasing by 3 every time. So if I really wanted to extend it farther, I could just increase by another 3. I don't even need to know what my value is or solve for it and put it on the table. I can just automatically know it's going to be increasing by 3. What if I'm going backwards? What if I want to increase farther on the left? So I'm going to subtract 3. So I'm going to go left 1, down 3. Left 1, down 3. And keep going and going, and I can keep going all the way down. And so this will be my line.
That's
Back.
not even coach.
Now, thinking back to y equals mx plus b, what type of equation do we call this? It's an algebraic equation, but it's also called a linear equation. Now, if we think about this, the root of the word linear is line. So that's anytime we're talking about a linear equation, they will always graph lines. So So anytime we're graphing something of the form y equals m, it's supposed to be, it should always be a line. If you're getting something that's not looking like a line, we're probably messed up somewhere, and we need to reevaluate.
What happens if you
Well,
get a
luckily you were able to learn a lot of it last year, so we can build off of that. So thinking back once again to y equals mx plus b, what is that plus b called again? Y-intercept. Now if I look at this if I look at this graph, what do you notice is happening at 2?
It's a wire.
The y-intercept, that's where I'm crossing my y-axis. So another way to start, if you're really lazy and you don't want to make a table every time, all we need to do is look at that y-intercept. Plus 2. I know that's always where I'll be crossing my line. So I know I'm always going to start at this line, or on my y-axis, I know I'm going to be crossing at 2. So I can put a dot at 2, and from there, I can look at my slope. Plus 3, you see, oh, I just need to go up 3, up 3, up 3. And there I can graph my entire line without even having to create a table. So if you don't like creating a table or you think it's too time consuming, plot that y-intercept and then go up by your slope. That's a quick strategy you can try. Are we okay with graphing for right now? At least this situation? All right. So here's another situation. Laura is 7 miles away from her house. She is walking at 2 miles an hour. Create an equation that represents the distance Laura is from her house after X hours. So let's think about this. What is changing in the situation? The time. So what is time going to be? So time is going to be your X, your independent variable. So I know I'm going to have an X. That's going to represent my hours. After every hour, what's changing? What's happening each hour?
2 miles.
So she's walking 2 miles. So if X is my independent variable, the distance from Laura to her house is the dependent variable. That's going to be my Y, her distance. Now if she walks 2 miles, is she getting closer to her house or farther away? Closer. So is this distance going to be increasing or decreasing? Decreasing, because she's going to get closer every time. So then this 2 that I'm changing, my slope, my constant rate that's changing every hour, is this going to be a positive number or a negative number? Am I adding to my distance or am I decreasing from my distance? Decreasing, so it's going to be a negative. So in order to figure out some of these signs for these numbers, whether it's going to be a positive or negative, we have to think back to the situation. What is happening? Am I adding to a distance or am I taking away from a distance? Am I adding to an amount or am I taking away to an amount? So that's my Y, my output, that's my slope, my input. What else am I missing? My y-intercept. I need to figure out what the initial amount was. Where did she start at 0 hours before anything has happened? She started at 7 miles away. So my initial amount is 7 miles away. I'm decreasing by 2 hours or 2 miles every hour. So let's graph this.
Graphing is hard.
It is. So let's walk through this. Okay. To start off, without making a table, I need to find my y-intercept. So my y-intercept is 7. So I know I'll be crossing my y-axis at 7. What's my slope of my line? -2. It's that number in front of the x. So that means every time I go over one space, I'm going down 2. So over 1, down 2. 1, down 2. And I can keep going all the way. Yes. Now, some of you might think, well, eventually, she's going to hit 0 distance away from her house. She's going to reach her house. So there's really no point in graphing beyond that. But if you wanted to represent the whole line or the whole graph of this equation, rather than just the situation, you could extend it farther into the negative distance. Are we okay with this? With graphing this line?
Yes, good.
All right. I think someone said something about Star Wars earlier, so we'll throw this in.
That was me.
What'd you say?
I said he looks like the guy that goes to Star Wars.
Thank you.
You're welcome.
So Luke Skywalker, he's harvesting moisture on his farm at Tatooine because he's a moisture farmer. Well, before he was a Jedi. So he's only able to collect 3/5 of a gallon per hour. He has already passed, or he already has 2 gallons. So he has 2 gallons. He's collecting 3/5 of a gallon every hour. We want to create an equation that represents the number of gallons he has after X hours. So once again, X is going to be our hours, it's going to be our time. Y is going to be how many gallons he has after that X number of hours. How much does he start with? What's our initial amount? 2. So that's going to be our x-intercept. How much is he gaining? 3/5 of a gallon. Okay, good. So this is where it's going to be a little bit trickier. 3/5 of a gallon. In drawing by 3/5 of a gallon or increasing by 3/5 of a point, that's going to be a little bit harder. How are we going to go about graphing this? What are some thoughts? Or where should we start? Let's start. Where should we start? 2. Okay, 2 is our y-intercept. I know I'm going to start at 2. Now I need to increase by 3/5 of a spot. Does this look like 3/5? Is that 3/5 or is that 3/5? Is this 3/5? I don't know. It's a small spot. It's hard to tell.
No, I think you can fill up like one.
So I think yesterday when we dealt with a situation like this, we had increases of 2/3. We were increasing by 2/3 every time. So what we did was we created a table to help us represent that. So if we were to create a table in this situation, we started at 0.
Luke is coming. Why would we have to do it for him?
Who's weak?
Luke Skywalker. And that's why you're failing this class.
Exactly.
All right, so if we were to create a table, we start at 0. We know at 0, we're going to be at 2. If we were to increase by 2/5, or I can't talk. If we were to increase by 3/5, we're only going to change a little amount the first time. Let's add on another 3/5. Why not? So if we add on 3/5, 3/5 plus 3/5 will give us 6/5. We can fix that around and make it 3 1/5. That's still not an easy number to work with. Let's keep adding.
Oh, that's good.
Add another 3/5, and we are at 3 4/5. Still not a nice number. I don't like it. Let's keep adding. Add on another 3/5. 4 2/5. I don't know. I still have a fraction. I don't like those fractions. Let's do one more. So add another 3/5. What does this put me at? Exactly 5. So I have whole numbers here. I have whole numbers here. How many spaces did it take me to get to another whole number?
5.
It took me sort of like 5 tries. How much did I increase by?
3/5.
In total, over those 5 times, it took me, I increased by 3. What do you notice about this? 3 and 5. What does that relate back to? 3/5. So every 5 spaces, I'm increasing by 3. So whenever we see something like this, a slope that's a fraction, in order to graph it, we can do something that you probably did last year called rise over run. So my rise is 3. I'm going to go up 3 spaces, over 5 spaces. 1, 2, 3, 1, 2, 3, 4, 5. My rise over my run. Rather than having to place those like ugly 2/3 or 2 3/5, 3 1/5, all those ugly numbers, I can place these whole numbers by using rise over run. So up 1, 2, 3, over 5. 1, 2, 3, 4, 5. And I can keep doing that the other way as well. I can keep going backwards. So I could go down 3 to the left by 5. Down 3 to the left by 5. And we can do this to get our whole run. So anytime you have ugly numbers, ugly fractions in that slope, don't freak out. Don't think, oh no, I'm not going to get this accurate at all. Use that slope and use that rise over that run. Are we okay with this? Okay. I have another situation. All right. Make your own situation. Switch with a partner. Practice and graph it. Got a situation? Try to keep your situation somewhere in the single digits because your graphs only go up by only go up to 10. I already have the graph on there. Try to keep your situations increasing by single digits. Depends on how much time. 15. Almost enough. Oh, yeah, 9. I was looking for 5.